Unit 5, Day 6. Equations, I guess really not equations, more like word problems. We have to look at some specific equations that involve logs and exponents. So the first one is interest compounded either monthly or daily or weekly or quarterly or annually. We're going to come back and go ahead and write them all down because we're going to go back in a little bit and put something next to those. And if you remember, that's as opposed to compounded continuously, but that's the next equation. A equals P times 1 plus R over N to the NT. Again, you will have your notes for the test. All the equations will be provided. So your job is to make sure you understand what all the variables mean, all the variables stand for, and how to use them. A officially is amount, but I like to think of it as the after. P officially is the principal. That's the amount of money you start with. So to me, it's easier to think of P as pre. Because the biggest mistake people make is getting the starting money and the ending money like backwards, which one goes where. So instead, if you just remember pre and after, then that makes it a little bit easier to know what to put where. R is the rate. Although you got to be careful here because 7.5% would mean that R equals, do you remember? 0.075. You move the decimal 2 places. So 0.075. If you could somehow get a 10% return on your money somewhere, that'd be great. R would be, what would R be if it's 10%? 0.1. So be careful with R's. N is how often your money is compounded. The number of times per year. That your money is compounded. So let's go back up to what we wrote earlier. Daily, monthly, weekly, quarterly, annually. There may be others, but we'll stick with those. So annually means N would be 1. It's compounded once a year. If it's compounded quarterly, what would N be? Do you know? 4. It's 4 quarters in a football game, and there's 4 quarters in a year. 4 quarters in a dollar. So 4 per year. If it's compounded weekly, what would N be? 52. Monthly is 12. Daily, I guess we'll go 365 and assume it's not a leap year situation. 365.25, you really want to get technical. So N, you have to be careful with because it's not going to come out, the problem's not going to come out and say what N is. It's going to use a word like daily, monthly, weekly, quarterly, annually, and you have to know that how to translate that into N. And then T is time in years. I think I just want to walk through all 4 of the problems or the equations, and then we'll flip it over and do some problems together. So equation number 2 is if it's compounded continuously. if it's continuous growth. This doesn't really happen for money. Your money is compounded monthly, probably at a bank. It'd be nice if it was compounded continuously. This is more for things that are continuously growing. So sometimes, well, I don't even want to say it because that might lead us down the wrong path. But compounded continuously. Here's the equation for that. A equals P e to the RT. P times e to the RT. Yep, the PERT formula. We can still say A is the after amount, P is the pre amount. So the before amount and the after amount, what you start with versus what you end with. Again, officially it's principal and amount, but just call it after and pre. E is just a number. It's a number in the calculator, so you don't have to worry about that. The calculator handles that part. R and T are still the same thing. R is rate, with the same caution about 3.7% is 0.037. And T is time in years. So the big deal with interest is whether it's compounded continuously versus daily, monthly, weekly, quarterly, annually, whatever. So continuously is the kind of the key word you're looking for when you're working the interest problems, because that's your clue to use the PERT formula. Right, half-life formula. This is kind of a chemistry thing. So if you've had chemistry or in chemistry, you know that there's some. I should probably stop talking about chemistry. I'll mess this up. But there's some elements or compounds or whatever that decay, and when they do that, they follow this formula: A equals P times 0.5 to the x over h. The half-life formula. It's pretty easy to know when to use this one, right? If we're talking about half-life, then you should probably grab the equation that has a half in it. So picking the right equation for this one isn't really difficult. A is the after, P is the pre, so that's kind of be standard on all these problems. How much plutonium do I have after 500 years versus how much did I have at the start, at the beginning, pre-decay. All right, X and H, people get confused, so I have to be careful here. X is the time in years. I'll just say of the experiment, so like how long the decay lasts. H is the half-life time. So H is fixed. H is constant for a particular element. Half-life might be 5,000 years. I mean, usually they're really long. They take a long time to decay. So H will be given to you, usually. Well, they'll both be given to you. It's just a matter of which one's in the top, which one's in the bottom. That's how people miss these problems. But the half-life that's given to you is the bottom one. The top number is how long are you going to let the experiment run? Or how long do you let the decay go on? And then lastly, population growth and decay. I'm going to write it a little bit different than the other side of the page writes it, because I want to keep using A and P. Because I like the pre and the after stuff. I don't know that we need to write it again, but just so that you'll have it all nice and organized. A is the after, P is the pre. On the worksheet you get, it says f of x equals p. But why bother with f of x? Let's just use A for after. R we know is the rate. X is the time in years. And then the plus or minus thing, you don't do both. Right? You do plus if your population is growing. You do minus if the population is decaying. So the formula won't be given, and it won't tell you which one to use. But you'll have to read the question carefully, because it'll say population decays by 3% a year or grows by 5% per year. So you have to make the right choice on which one to use. All right, so today's notes page, we can work some of these together. If 4,000 is invested at 8.5% compounded monthly, so there's our key giveaway word there, or compounded monthly, not continuously. How long will it take to reach 7,500 in the account? She'll work and round to the nearest penny. Whoops. If we're asking how long, we're not rounding to the nearest penny, so that's a bad question. Right? How long does it take? 3 years rounded to the nearest penny. That doesn't make sense. Okay, so compounded not continuously is this first one. So A equals P, 1 plus R over N to the NT. Let's list out what we know, list out what we're looking for, and then we'll plug it in and see what we need to do. So 4,000 is invested. So 4,000. Which variable is that? That's the pre. That's what we're starting with. At 8.5%, I'm going to change that to 0.085 because that's the rate. Again, 2 decimal places. Be careful with the rate. How long will it take? So that means we're trying to find time to reach 7,500 in the account. Well, that sounds like 7,500 is the after amount. After so many years, we have $7,500. So we're looking for T. We know A, we know P, we know R. What's N? 12. Because again, it's never going to tell you what N is. You got to use the words in there to figure out what N is. So let's fill in everything that we know and see if we can find what T is equal to. 7,500 equals 4,000 times 1 plus 0.085 over 12 to the 12T. So trying to get T by itself. Thoughts on what we should do first? Try to start peeling off the pieces to get to T? What's that? Okay, I could deal with this. I could type that in the calculator, but it's going to give me a weird decimal. So I don't really want to mess with it right now. But you can if you want to, then you just got to write it down every time. So I'm going to divide by 4,000. That might give me a weird decimal as well, but let's see. 7,500 divided by 4,000. 1.875. Well, that's not too bad, I guess. And then I guess I could type that in. I'm going to have to type it in eventually, so either way, 1 plus 0.085 divided by 12. And that's what I figured was going to happen. That's a really ugly number. So I think it's probably easier to just leave it as written. if you want, if you know how to store it, you can do a store. So you hit the stow button, store it as any kind of letter you want. So you can store it as A. And then you can use A every time instead of writing it all out. Let's see, I've got variable in the exponent, so I will log both sides, or natural log both sides, either one. And the reason we do that is to get that 12t down to the front. Lots of writing, lots of ugly numbers. Okay, there's t. I'm trying to get it by itself. And I have 12 times t times some ugly number. But this is fine. I'm almost there. If I want to get t by itself, what could I do to undo the multiplication? Divide. So let's divide by everything that's not t. So kind of ugly to get there. Let's see. I may want to go with the fraction bar for this one, rather than worry about all the parentheses that I would have to do. So natural log 1.875 over 12. Natural log 1 plus 0.085 divided by 12. $7.422, and since that's time, it's in years. That was a lot of steps in that one. That one would be a really good one to try to check your answer on. But I'm running out of time, so I'm not going to check my answer on that one. Number 2. You deposit $9,500 in an account that compounds continuously. So that's the PERT formula. How long will it take for the money to quadruple? Well, it doesn't give me the final amount, but what does quadruple mean? Times 4. So 9,500 times 4. 9,500 times 4 is 38,000. So I'm skipping a few steps here for time purposes. E to the 0.0725 t. What do you want to do first on this one? Same thing we did first last time. Let's divide by 9,500. What are we going to get when we do 38,000 divided by 9,500? 4. So maybe if I'd been paying attention, I could have started that way. Let's natural log both sides to get that ugly stuff out of the exponent. Do you remember what the natural log of E is? I don't know if you do. If you don't, that's fine. You can type it in your calculator and you'll get the right answer. But the natural log of E is 1. So this one turns out to be a pretty, I don't want to say it's an easy problem. It's an easy one to enter into the calculator. There's less steps. It's just natural log of 4 divided by 0.0785. So t equals 17.66 years. Let's see, that's... Did I switch? Oh, I sure did. I messed up and then I wrote it down wrong the whole way through. .0725. So it actually will take 19.12 years. All right, so try the ones on the other side, or 17 through 21. We'll have to do a Half-Life problem tomorrow, but that's okay. It's only 5 problems, so give them a go.